Our splash screen is looking really good, but traditionally the splash screen has to splash. That's why it's a splash screen, which means you should either have some sort of animation that terminates into the next screen, or it should just show for a little bit and then go to the next screen. Either way, it should not stay there. So how do we do that? Well, what we're going to do is we're going to create a splash screen. In a sense, we're going to have an animation that will kind of enhance this image and then retract. And then once that animation is over, we're going to then navigate to the main screen. All right, so back to our animation, right? I should say back to our weather splash screen, rather. What we're going to do here is at the top, first of all, let's go ahead and get rid of unnecessary things here, remove redundant qualifier. So at the top of our function, weather splash function here, I'm going to create a variable. It's going to be val scale. So what is this scale? Well, the scale is going to be used to control the state of our animation, but most importantly, the scaling of this structure that we created, because we want to create the scale effect that scales up and down. So we're going to put that into a variable, but not just any variable. We're going to use remember such so that the composable function will know how to deal with this, right? Will know to be triggered to change, to recompose if changes are noticed in this variable, right? And then I'm going to use another type here called animated table or animate table, that one. And then inside, I'm going to pass the initial value. So we need to pass the initial value. It's going to be at 0f. Whenever you have issues, or you want to understand exactly what a function or what certain class, the documentation, what it means or what it does, I always like to hover over, right? So if you hover over, it says this animate table function creates a float value holder that automatically animates its value when the value is changed via animate2, which we're going to see in a second. So we have our scale variable, which is attached to this animate table with 0 as its initial value. To use that, we have to pass that value inside of our surface, because the idea is that the surface, which holds this column, image, and text, and so forth, so all of this, we want to scale it depending on the time, the surface in this case, which is this, what we created, right, which includes the image as well as the text. We want to scale that. So we need to pass this value, which will be changing in a second here, depending once we put together the animation. And we need to pass that inside of our surface. And how do we do that? Well, we understand that our modifier here, among many other things, there are other things we can pass along with it. One of which is going to be the scale. So we can actually pass a scale. So in this case, I'm going to pass scale dot value. That means even though the scale is at 0 at this point, in fact, if we run, we won't see anything because this is going to scale to 0, right? But the idea is that later, in a bit here, we are going to attach the scale to change depending on the animation as the animation happens. Alt Option Enter, and we're going to put everything in one lines to organize our code. Now, to create that animation, right after our variable, where we created that variable, here I'm going to create a new structure called launched effect. Hit enter, and we need to pass a key. I'm just going to say true, and the block. The block in this case, what I'm going to do is I'm going to put the actual block of code that we're going to be using. Okay, so what is this launched effect? If you hover over, again, it's going to say when launched effect enters the composition, it will launch block into the composition's origin text, context, right? What it means is that when this happens, the moment this is called, we enter this composition to create this view so users can interact with. What happens, this block, what we're going to write inside now, this coroutine, like the back end or the background workings, right? Asynchronous background workings, things that happen in the background and so forth, and will be canceled and relaunched when the launched effect is recomposed with a different key. So all in all, to say, whenever we want to pass certain processes, in this case, this process of animating something, changing the structure of our view, we are going to pass inside of this launch effect because we get this coroutine scope which allows us to do this work that usually needs to be done away from the user interface. Now, when it comes to coroutines, there's a lot to learn, and it's a big topic, but essentially this is what we're doing here. So inside here, this is when we can just use our scale variable, right? We create it at the top there. And then we're going to say dot animate to, because remember, the scale is implicitly an animatable type. That's why we're passing this animatable initial value 0. That's why we can actually use the animate to function. So we can then pass the target. In this case, what is the target value? The target value could be anything, but we're going to say 0.09f. Okay. And then next, we're going to pass the animation spec. Okay, what kind of the animation we're trying to create, trying to have here. There are different kind of animation, but in this case, we're going to use the twin spec like that. Okay, I can even put the named argument, say animation spec, say twin. If you have over again a twin, there's different kind of animations. It says creates a twin spec configured with the given duration, delay, and easing curve. Now the parameters we're going to pass in this twin, as you see here, could be duration in millis, which is the duration of the animation spec. And then we can pass delay millis, the amount of time in milliseconds that animation waits before starting, and then easing, the easing curve that will be used to interpolate between start and end. So essentially, we're going to pass all of these values that we need to pass here, because the animation will interpolate between two values, the target and the initial value, 0 to 0.09. In this case, I'm going to say duration, how long, just say 800 milliseconds, okay, so 0.8 seconds really. Pass easing, right? The easing, of course, it is a lambda, I can pass it there. So now I can invoke different kinds of easings, right? So I'm going to say overshoot, for instance. That's what I need, overshoot interpolator, to interpolate between those two values. And then I'm going to say, here I'm going to pass the tension, and then I'm going to say get interpolation and pass IT. So looks like very complicated code in a sense, but not really. So we're just creating this structure that will allow us to scale this value here, which is an animatable. Okay, so we animate to, we pass in the target's 0.09 from 0, of course that's initial value, and we need to pass the kind of specs of the animation. What kind of animation we want? Well, it's going to be a twin. A twin, in this case, we need to pass duration in milli, how long will it animate, and the easing, what type of the animation we really want, right? In this case, we just want overshoot interpolator. We're going to interpolate between the initial value and the target value with tension of 8f. So obviously, if you want to see the difference, you can change this tension. I'm assuming the greater the number, of course, the more tension it will show. We are using overshoot interpolator and pass the tension, and then get interpolation, pass the IT, which is the float that we get from our lambda there. So you see now our scale variable is going to interpolate, it's going to change, it's going to, in this case, create that animation we want. Let's see if this is true. Let's run. You saw very, very, very little there. Very little. What's happening? Maybe we added a different animation. Instead of, there we go, the target is really small. That's why you saw that. So instead of 0.09, let's say 0.9. Aha! Now you saw the difference. Let's go ahead and run again. Voila! You can see it works. So the smaller this number, of course, the smaller the animation. We had 0.9. 0.09, you can see it's very small. That doesn't make any sense. But if we put 0.09, or rather 0.9, you'll see that we're going to get the results that we want. Voila. Very good. So that's exactly what I want. What we really want to happen is once this animation is over, right about here, we want to also delay for a few milliseconds and then navigate to the next screen. So because we're still inside of this launched effect, we get to invoke certain functions such as delay, voila, different flavors here. Then here we pass the milliseconds or the time we want to delay it by. 2000 milliseconds. I'm going to put L for long. This is about 2 seconds that we want to wait once the animation is done, and then we're going to do something else. What we want to do here is we want to go to a different screen. Which screen? Well, I'm going to say navigator, or nav controller I should say. And now, before I even move forward, let's see what's happened here. I have nav controller. Where does that come from? Well, it comes from here because we made sure to pass this nav controller along, so we have this capability of say nav controller because it's the controller. It knows how to do things such as pop back stack, removing the screen that users are seeing to go back, or navigate to somewhere. All right, where we want to go. Now make sure there's a lot of different overload functions here. Make sure you get the route, right? Because we are going to use route. That's where we're going. So use the route one there to navigate to wherever we want to go. Where do you want to go? We want to go to weather screens. Look how wonderful this is. Oops. Screens. Remember, we want to go to our enums, and then I'm going to say main screen, that name. Just like that. That's where we want to go. Now let's go back to our weather navigation to make sure that we have that composable this screen. We don't have that, which means I'm going to copy this and create, right? Because we have to go to our weather navigation, which has a nav host, and we have to add that screen to go to. Because if we just call a navigation a screen that hasn't been created, then we would have a problem. All right, so I'm going to change a few things here. In fact, I'm just going to change this to main screen. And then here, it's going to be main screen. And we haven't created that. Let's go ahead and create main screen. That means then we go to our screens again. And let's go ahead and create a new Kotlin class. It's just going to be a file. Call this main screen. And it's going to be a composable. Call this main screen. And as always, we're going to pass our nav controller. As we've learned, it's a good friend to have around. And for now, let's just put a text here that says main screen. Okay, so now we have our main screen. We know that we're not going to be calling something that doesn't exist. Let's go ahead and import that. If we can do it right, import. We want this main screen there. Oops. Make sure we get that one, and we should be good. Now, if we run this, hopefully, after 2 milliseconds after our animation, we should go to the main screen. And there, voila, there we go. We have our main screen.